Hello friends. So now going for the question number 2 on the same exercise. That exercise is 1.2, practice at 1.2. So they have given the second question as what? In triangle PQR, PM is equal to 15, PM is equal to 15, PQ is equal to 25, PR is equal to 20 and NR is equal to 8. State whether the line NM is parallel to the side RQ. Give reasons. Okay. If you will try to understand, so they have given, if we go for the solution part, so what we can write, if I write as a solution, so in the solution, very simple, we can say that if we have PM is equal to, PM they have given 15, okay, if we go for the next one, so they have given what? PQ. So PQ is nothing but PM plus MQ, so we can say that the PQ is equal to PM plus MQ. So we have PM value that is 15, MQ is unknown, but PQ value they have given 25. So we will write 25 at this place. So therefore what we get 25 minus 15 that is equal to MQ. So MQ value we get as a 10. So MQ value now we have what? 10. We have MQ is 10 and PM is 15. Okay. If we go further, so again similar manner, we have PR value. So what they have given PR? So we have PR that is equal to PN plus NR. PN plus NR. So very simple, if we go further, so we have value of NR. NR is how much? So in NR they have given 8. So we will write 8 and PR is equal to 20. So if we take 8 on this side, so what we get? We get PN is equal to 20 minus 8. PN on same place, 8 will go on that side, that will come 20 minus 8 and PM is equal to 12. So this is what representing 12. So PN we can write 12 and NR they have given us what? 8. So we will write 8 as this place. Okay. See, this is a diagram exactly equal to the what? This one is working like a BPT theorem diagram. Okay. So this is what a triangle, this is a triangle and they have given NR as a, NM is a line which is what? It is looking like a parallel to RQ. That we have to what? We have to prove that state whether the line NM is a parallel to QR or not. RQ or not, this we have to prove. To prove this, what we will give, and we have to write reason also. So very simple. If we go for the BPT theorem, so they have given that line is what dividing a side opposite to a side, that line is what dividing remaining two sides in the equal ratios. So very simple. We will write from diagram, in this way we will write from diagram, we can write PN divided by NR and that become 12 divided by 8 and this is nothing but what? It is divisible by 4, so we will write 4 3s and 4 2s. So now this is what? The first equation. Similarly, if we write PM divided by MQ, so we can write 15 divided by 10 and this 15 and 10 is divisible by 5, so we will write 5 3s are 15 and 5 2s are 10 and this is what equation 2. So we can say that from equation 1 and 2 we can say that PM divided by NR that is equal to PM divided by MQ. Okay, as we know that this condition is only possible when NM is parallel to RQ. This condition is only possible when NM is parallel to RQ. This is the last statement of the BPT theorem. So now we have the statement. So we can say that by the property of the BPT, that we can say, or other than this, as a reason, we can write the converse of the BPT. The converse of the BPT and BPT. What are the difference between the BPT and the converse of the BPT? BPT is what? In BPT, they have given this line is parallel to this side, and we have to prove this ratios are equal. But in converse of BPT, they have given this ratios are equal, then we have to prove these two things are parallel. So now we have this ratios are equal. That means what? This will come under the converse of the BPT. So we will write as a reason by the converse of BPT. Therefore, by converse of BPT or basic proportionality theorem, you can write. We can say that NM, line NM, we will write line NM is parallel to side RQ and hence prove. This was our requirement and that we have to prove. Okay, so that we have proved. This is the reason that by converse of BPT, these two things are parallel. I hope this one is clear now. We will move to the third question. If you have any query or any doubt, you can directly text or you can ask questions after watching this video. Okay, so now come to the question number 3. In question number 3, what they have given? They have written as M and P in triangle M and P. This is a triangle. In that triangle, NQ is what? Bisector. This NQ is representing as a bisector an angle of what? Angle M. So this NQ is the bisector of angle M, and we can read this one as a M and P or a P and M also. So they have written directly angle M. If they have given Mn is equal to 5, Pn is equal to 7, and Mq is equal to 2.5, then find QP. We have to find what? This one. So simply, if we want to solve this one, so very simple, we can say that this one is looking like what? This diagram is looking like a this one is looking like a what? Angle bisector. So we will go for the angle bisector, and simply we will say that in triangle M and P. So they have given in triangle M and P, NQ is a bisector of angle. NQ is a bisector of angle M. Therefore, these two conditions, see, listen, in triangle M and P, NQ is the angle bisector of angle M. If we have this condition, so simply we can say that by the angle bisector property. So when we are using angle bisector, we have to keep in our mind, in the question they have given that NQ or that ray or that line is a bisector of the angle. If we have any angle bisector, then we can apply the angle bisector theorem. So very simple, we can say that therefore by angle bisector, we can simply write, I told you all that if we are starting from if we are taking M as a vertex, so we will write MQ divided by QP, and that ratio become Mn divided by NP. See, we have started from point M, but the ratios are what? Starting from point M. So we have written one ratio as a MQ divided by QP, and the second ratio we have to write what? Mn divided by NP, not Pn divided by Nm. If I will write Pn divided by Nm, that equal to MQ divided by QP, that become wrong. So we have to keep in our mind, we have to start what? Both the ratios from the same point, and we are starting from the what? Point M. Okay, if we go further, so in question they have given what? That NQ is equal to 2.5. So in place of MQ, we will write 2.5. We need what? Value of QP. So we need value of QP. So QP is as it is. If we go further, so we have Mn value, that one is 5, and NP value is 7. If we do cross multiplication, so very simple, if we go for the cross multiplication, so this term will what? Go on that side and this one on this side. So this can be written as 2.5 into 7. That is equal to 5 into QP. So if we go further, so 2.5 into 7 divided by 5, that is equal to QP. So very simple, as we know that 25 and 5, see this one is representing 2.5. So if I will multiply by 10 to up numerator and denominator both, so that become 25 upon 50. So that become 1 by 2. So very simple, if I will multiply by 10, numerator and denominator both. So this ratio become 25 into 7 divided by 50, that is equal to QP. If we go further, so these two things will get cancelled, 25 ones and 25 twos are. So now we have 7 divided by 2, and 2 can cancel that 7 in 3.5. So very simple, we can write QP as a 3.5. So this is the what? Value of the QP. I hope this one is clear. Again, I am repeating one more time. See, in question they have given M and P, in triangle M and P, NQ is the angle bisector. So as we know that we have any angle bisector, so simply we can apply what? Angle bisector property. When we are applying angle bisector property, we have to keep in our mind that we are using for both the ratios the same vertex. We are starting from the same vertex. So see, I have taken M as a vertex and I have written MQ divided by QP. So I have to write the second ratio as a Mn divided by NP only. So these two things are the what? These two things are the ratio. See, according to the ratio, we have written these two things and they have given values of the few things. So we will substitute those values and only QP is what unknown. So we will keep QP as it is and we will solve that one. So we get what QP value as a 3.5. I hope this one is clear. Thank you very much.